Okay, minasan, konnichiwa, Zamurai Engineer desu. So in this live stream segment of lecture, we are going to discuss Part D, the sub-base and the base course portion of the Department Orders for Materials Engineer. Before that, I would like to ask somebody for confirmation of sound. Okay, so thank you, Daniela, for confirming the clarity of sound. So therefore, let us proceed. So only Daniela returned. Okay. Where are the others? Second is Zairid. So there are only 2 students. Josh. Okay, so okay, let us proceed while the others are arriving. So while they are arriving, like we can actually do the presentation. Okay, so I cannot check it out, so I need to check it on my own. Okay, let's try it. Oh, there are only 5 students, so including me. So I am the 5th one, so there are only 4. Anyway, even though we are only 4, so we can still proceed with the lecture. So what you can see right here in your screen are the components of, how to do it. What happened? Hi. So on your screen, we have the layers of subgrade and pavements, up to pavement. So as you can see, there are letters A, B, C, D, E, F. Okay? So letter A, this is what we call layers of pavement. So letter A, that is what we call subgrade. So as you can see on the subgrade, more on big diameter granular materials. Okay, so more on maybe bigger than gravel, or maybe the size of gravel. So it is supposed to be bigger. Okay, so letter B, that is what we call sub-base. Okay, so A is subgrade, B is sub-base. So A is the sub-base, and B, A is the subgrade, B is sub-base. Okay, okay, understood? B sub-base, A subgrade. So subgrade could involve soil. Okay, subgrade could involve soil. B majority in B are what? Are sand and gravel. Okay, you can also use other materials. Okay, and letter C, that is the base course. Okay, base course. Course meaning layer. Okay, the base course. Okay, so another meaning of course is recipe. Okay, so A, B, C, D, E, F, they are of the different recipe. They could be composed of the same material, sand, gravel, for example, but they have different recipe. Sometimes A with the inclusion of soil, B without what? Without, for example, without paste. For C, we can add some small amount of paste. Then letter D, that is the paver base. Paver base or pavement base. Okay? And letter E, that is paver. That is paver. So paver meaning from the word pavement, that is pavers. Okay? So pavers spelled out as P-A-V-E-R. Okay? Paver. Paver. And letter F, fine-grained sand. Okay? So this is what we mean by this diagram. Okay? So with the knowledge about the diagram, let us now go to the discussion. Okay? So we already know what do we mean by sub-base and base. Okay? But we do not have base on that diagram. Okay? Let us repeat. Where is this? Where is the base in the diagram? We know the sub-base. Okay? Sub-base is letter B. The layer B in your screen, that is the sub-base. And letter A is subgrade. Where is the base? Okay? It is not indicated. Where is the base? Because letter C is base course. Letter D, paver base. Letter E, paver. Letter F, fine-grained sand. So the base is actually letter C, base course, but it also involves D, E, F. So C, D, E, and F. Okay? Those are the base. Okay? Okay, so actually usually C, D. Okay? So but in this particular example, C, D, E, F. Okay, so that is what we mean by base. So sub-base, letter B, base, C, D, E, F. Okay. Return back to the document. So therefore, item 200, aggregate sub-base course. Okay. How do we proceed and describe? Number 1, maximum compacted thickness of any layer based on department order number 70, year 2016, shall not exceed, okay, shall not exceed 200 mm. Okay, so shall not exceed 200 mm. It was 150 mm before, but now it is 200 mm. So the old one, 150 mm. Now it is becoming 200 mm. Okay, so 200 mm, that is 8 inches. 150 mm, that is 6 inches. Okay, maximum compacted thickness of any layer base. Okay, so that is 200 mm. Number 2, just like embankment, so we are just talking right now of sub-base, that is item 200, sub-base, 200 mm. Just like embankment, there will be one trial section of about 500 square meter shall be made for every type of material, construction equipment, and procedure proposed for use. So if you propose a change in procedure, or if you propose a different type of material, okay, so therefore, or if you propose the use of a different equipment for what, compaction equipment, ruler, for example, you have to use that proposal as a trial, do it in about 500 square meters, trial, then test, then submit the result, and then get approval. So that is the procedure. Okay? Okay? Are we clear? So for item 201, item 201, aggregate base course. So we are now on the base. So layer C, D, E, F. Okay. Filler shall be taken from sources. So filler that is the layer F. Okay. Of course, that is included as the base. Okay. Course. Okay. That is layer F on the diagram. Okay. Free hard lumps and shall not contain more than 15% of material retained on 4.75 mm sieve. Okay? So 4.75 mm sieve. Okay? So shall not contain material greater than 4.75 diameter. Okay? That is what we mean by that. So if ever there are more than that, only 15% could be more than that. So meaning mostly sand. That's why the layer is, come again, so the layer is like this. That is letter F in your screen. That is letter F. So that means those are sand that must be small enough so that it could be a filler. That is a filler material. Okay? Usually sand. So the definition of sand is less than 4.75 mm. Actually 4.76 mm in geotechnical engineering. Okay? Any question? Do you have questions? So again, next. Number 2, compaction layer shall not exceed 200 mm, just like embankment and sub-base course. Okay? Compaction layer shall not exceed. So again, 200. So again, this is 150 mm on the old. So what I know about is the old one. So 150 layers. Okay? Now, DPWH uses 200 mm. If this document is correct, this is order of DPWH TO70-16. Okay? And item 202, crust aggregate base course. Okay? Item 203. So the key points are the following. Okay. Number 1, dehydrated lime shall be uniformly spread at the specified percent using the dry or slurry method. Hydrated lime, that is equivalent to cement, okay, shall be uniformly spread. So cement shall be uniformly spread using dry method or wet slurry method. So if the road is actually moisturized with water already, so you can use a dry distribution of cement all along the proposed road. It will become paste, reacting with water and bonding the different size of particles in its vicinity. Okay? Number 2, a typical slurry ratio is 1 ton lime to 2 cubic meter water. Okay, 1 ton. 1 ton lime. So 1 ton, for example, cement, 1 ton cement, 1 ton and 2 cubic meter water. So 1:2. And number 3, trial sections shall be constructed at least 2 weeks before actual base construction. Trial section, 2 weeks. Okay, so that there is a time for evaluation of of the testing and the inspection and proper modification could be done before the actual base construction. 2 weeks. Okay. Number 4, if excavated materials are wasted, meaning they are unsuitable material, the volume involved shall be reported so that quality control requirements may be adjusted accordingly. Submit project engineer certificate of waste. So, in terms of report, must be reported, documented properly. Meaning, project engineer certificate, so the project engineer must certify that this amount is correct. Okay? Okay. That is what we mean by that. So next is item 204, Portland cement stabilized road mix course. Okay. There are nothing under this. 205, there are nothing under this. Asphalt stabilized road mix base course. Okay. Item 206 is about chemically stabilized road mix sub-base base course. Okay. Chemically stabilized. Cement stabilized, asphalt stabilized, chemically stabilized. Okay. So 206, chemically stabilized, number 1, consists of application of polymer-based chemical soil additive to improve the strength and other properties of ordinary soil for use as sub-base or surfacing material. Sub-base is the layer B. That is sub-base, layer B. Okay. So we need the chemical, we need asphalt or Portland cement on that layer, sub-base. Okay. And number 2, what about number 2? Polymer based chemical soil additive shall be less than 2% by weight of soil. 2%. If you are using soil chemical soil, 2%. Okay. Soil additive shall be less than. Okay. So you can use 1% because these chemicals, particularly polymer based, they are expensive. They are expensive. So this refers to the maximum. Okay, 2% is the maximum by weight. And number 3, okay. And number 3, the rate of dilution in each. Okay, where is that? The rate of dilution of each layer shall be 1:5 to 1:9, or 1 part polymer and 5 to 9 parts of water. That is what we mean by dilution. The rate of dilution is 1:5 to 1:9. 5 parts water, 1 part chemical. Okay. And next, number 4. Unit of measure is liter, in terms of liter. 1 liter, 5 liters. Okay? And item 207, Portland cement treated plant mix base course. Okay. Number 1, salvage or new soil aggregate shall be pulverized until at least 80% mass percent of all material other than stone or gravel will pass 4.75 mm or sieve. Number 4. Okay, it should be pulverized. So therefore, there is a pulverizing equipment in DPWH or somewhere in the Philippines. I don't know. I need a pulverizing equipment that have this specification. I don't know how. Okay, but it seems there are at soil aggregate pulverizer. Okay. Number 2, A completed cement treated base shall be cured with bituminous curing seal applied as soon as possible after the completion of the final rolling. Okay. The rate of application of curing seal shall be between 0.5 to 1.0 liter per square meter. Okay. And maintained at least 5 days. Okay. The rate of application of curing seal. So, curing seal should be applied as soon as possible after the completion of final rolling. So, there must be a sealing process. Okay? Using what? Bituminous material. Okay? And number 4, so the application of seal is 0.5 to 1 liter per square meter. Number 4, any material retained on a 50 mm sieve. Okay. 50 mm sieve is a gravel. That is 2 inches. That is the size of the gravel. And other unsuitable materials shall be removed. So, meaning those more than the size of a gravel is not used in base layer. What is the base layer? Layer CD, EF. Okay. So next is item 208. Item 208, aggregate stockpile. Okay. So, number 1, consists of furnishing and placing of aggregate in stockpiles. Key points on allowable tolerances. So, stockpiles. Aggregate stockpiles. So, piling of aggregates. Okay. What are the supposed tolerances? So, we have a table here. So, item number 200, 201, and 300. So, there are following. So, for item 200, aggregate, so, thickness of layer. Okay. So, permitted variation from the thickness of layer. Plus minus 20. Okay. Plus minus 20 mm. Okay. That is the tolerance for the thickness of layer. So, remember, the layer is 200 mm or 150 mm. Okay. For the level of surface, positive 10 mm, negative 20 mm. Surface irregularity, positive 20 mm. And crossfall or camber, positive 0.3%, negative 0.3%. So, meaning plus minus 0.3%. Okay. For longitudinal, grade over 25 meters length, longitudinal grade, plus minus 0.1%. Take note, very precise. It's a very precise performance of construction project. Okay, plus minus 0.1%, longitudinal grade over 25 meter length. Okay, so for item that is for sub-base course. Now for item 201, that is base. For thickness, tolerance plus minus 10. So take note, sub-base plus minus 20, this is now plus minus 10. Okay, for item 300, surface course. So the surface, meaning the wearing surface. Okay, so that is what? Plus 15 mm minus 5 mm. That is the tolerance. Okay, then level of surface for aggregate base, plus 5, negative 10 mm. For surface course, 15 mm, negative 5. Surface irregularity, take note, 5 mm for base, 5 mm for surface course compared to 20 mm for sub-base. Okay? So for camber, that is 0.2% plus minus 0.2%. For item 201 and for item 300, that is positive 0.2%. So grade longitudinal over 25 meters plus minus 0.1%. Everything is plus minus 0.1% except the surface course, it is only positive 0.1%. So remember the precision. So if the layer is 150 mm, or let us say the surface course is only what? Surface course is only 10 mm. Only 10 mm is the surface course. Or let us say 20 mm. 20 mm the surface course. 0.1% of 20 mm is 0.2 mm. That is 0.1%. So you cannot measure 0.2 mm if the thickness of the layer of the surface course is 20 mm. You cannot measure 0.2 mm. That is so small. So remind of this precision, okay, of tolerance, right? So next, let us talk about minimum test requirement for these items. So for item 200, aggregate sub-base, for sub-base, for every 300 cubic meter or fraction thereof, 1G, 1P, okay? So 1G, 1P, okay? So G meaning grading test, P plasticity test, okay? And for every 1,500 cubic meter or fraction thereof, 1 compaction test, 1C, 1-C, okay? And then for every layer of 200 mm of compacted depth based on the result of compaction trial, at least one group of 3 in situ density test. So that is 1-D test. So 4 different tests should be conducted, okay, for sub-base, meaning layer letter B, okay? And then for layer C, D, E, F, so aggregate base course, for every 300 cubic meter, so the same basis, so 300 cubic meters. For every 300 cubic meter or fraction thereof, okay, 1G, 1P. So test it by 1G, 1P. And for every 1,500 square meter or fraction thereof, 1C test, okay? And for every layer of 200 mm of compacted depth per base, okay, at least one group of 3 in situ density test, okay? So density test per group is 3. There are 3 actual specimen, okay? For item 202, crushed aggregate base course, same as for item 201. So that is for every 1,500 cubic meter of fraction thereof, 1F. What do you mean by 1F? So this is additional to the 4 different tests made on item 201. So this is additional for item 202. 1-F meaning fractured face test. Fractured face test. So meaning the cracks on the face of the slab or the pavement must be measured, must be tested, must be evaluated later on. So item 203, line stabilized mix-based course. Okay. Letter A, soil aggregate for every 300 cubic meter or fraction thereof, 1G and 1Q. What do we mean by 1Q? That is quality test for grading, plasticity, and abrasion. Okay? Because we are on the road mix-based course, stabilized meaning it is with respect to the wearing surface. Okay? Quality test for abrasion. So, in our local language, test kung gaano kalapat yung kapit ng road surface doon sa gulong. Okay? Sa gulong. Abrasion. Okay? Dapat kapit na kapit. Abrasion. Okay? Dapat kumapit yung gulong doon sa surface. So, do not construct a pavement of roads that would slide or slip cars' tires. Okay? So, that is dangerous for the commuters in public. Okay? So, that is what we mean by Q test or 1-Q. And letter B, okay, letter B, we have additional testing here. Letter B, mix for every 300 cubic meter or fraction thereof, 1-C test, that is compaction. Okay? And letter C, compacted course for every layer of 200 mm part, compacted depth. Okay? And that is, again, last test is 1D, 1-D, meaning FDT for every 150 meters length or fraction thereof. Okay? Another test is 1-T test. Okay? Thickness determination for every 150 meters or fraction thereof. So you have to take a look at the layers and the thickness of those layers. Every 150 meters, imagine that. 150 meters, not 1,500. 150 meters. Okay? So for every 150 meters, we need 1-T thickness test. Okay? So there are plenty of thickness na test now. 1-Q, 1-T are added. Okay? In addition, we have 1-F. So there are about 7 types of tests. Okay? 7 types of testing. We have 1-G, 1-P, 1-C, 1-Q. Okay? So 1-D. Okay? So 1-F and 1-T. So there are now 7 types of tests. Okay? Okay? Then, next item. This is with regards to item 204, Portland Cement Stabilized Road Mix Base Course. So, item letter A, soil aggregate, same test as for item 203. Letter B, cement, 1-Q or quality test for every 2,000 bags of cement. For every 2,000 bags, quality test. Okay? So, cement. Then, water, as we tested. D, mix for every 300 cubic meter or fraction thereof. And letter A, compacted base course for every layer, 200 mm compaction depth. Okay? The layering now is 200 mm. Since 2016. Then, we have item 205, asphalt stabilized road mix. There are none. And item 206, chemically stabilized road mix base course. A, soil aggregate, same for item 203. Okay? And letter B, Portland cement, for every 2,000 bags, okay, 1 DASQ test or quality test. Okay. So remember the current number of different types of testing. So 203, there are 203 references here. So let us review 203. So 203, we have what? 6 different tests. 1-G, 1-P, 1-Q, 1-C, 1-D. What else? 1-T. So there are 6 type of tests. Only 1-F is not included. Okay? 1-F is what we call fractured face test. Okay? So next is item 207. Wait, so we have for item 206 still chemically stabilized road mix, we have letter C. Okay, so letter C so we have letter C is actually water. Okay, water 1-Q test. So quality, no? So we need what? We need the project engineer's certificate. Again, we need the field density test for every 150 meters, compacted depth. So field density test for every 150 meters length, but compacted depth is 200 mm. Okay, so that is 1-D. Therefore, 1-D field density test for every 150 meter fraction drop. Thickness determination is 1-T for every 150 meters. Okay, so there is what? There is a typo error here. There is a typo error. So there are 5 typo errors. Portland cement treated plant, that is item 207. Portland cement. So same as specified in item number of the specification. Okay. And item 208, aggregate stockpile, none. There is no test. Okay, so that's all for this document. Any question? Any question? So if there are no questions, hello? Any question? So if there are no question, we have to stop it right here and return back for the next live stream topic. Okay, we will return back immediately. Okay, we only have about 30 minutes left. Okay, okay, let's end it. Again, this is Dr. AP, preaching engineering.